this is for Year 10 Methods Pathways. We're going to look at exercise 10.4, question number 1. Now, this exercise is all about drawing tree diagrams. Okay, so question 1 is just to get you used to the notations in a tree diagram. So spinner is numbered 1 to 3, or we can see it here. So it's like a wheel of fortune. You've got 3 numbers on it. And let T represent the spin is 2. Okay, so if you spin a 2, that's T. So T means getting a 2, and N means getting a 1 or a 3. Okay, because it means getting a not a 2. Now, I know that out of the sample space, 1, 2, 3, the total samples, I know the chance of getting 2 is 1/3, which is why we have 1/3 here of getting a T, and 2/3 of getting not a T. Okay. Now remember, the forks have to add up to 1. 2/3 plus 1/3 equals 3 on 3, which equals 1. Okay, so great. So in the second branch, it's the same thing. The probability doesn't change. So that's 1/3, that's 2/3, that's 1/3, that's 2/3. The sample space, okay, it means a branch line. What are the letters on a branch line? So that's T and T, that's T and N, that's N and T, so N first T, then N and N. Okay, the probability of N and T is given by the branches multiplied together. So you go 2/3 times 1/3. Now when you're multiplying fractions, you multiply the denominator with the denominator, numerator with the numerator. So 2 over 9. We have to fill this blank in, so they've already done the fractions for us. We just got to multiply them. 2 over 9. And the last one would be N and N. Probably of N and N would be 2/3 times 2/3, which equals 4 over 9. Okay. Now we've got our probabilities. If you were to add all these probabilities, it will equal 1 in total. So total of that will equal 1. Okay, that could be useful later on. Okay, find the probability of spinning 2 twice. Okay, 2 means getting 2 T's, right? Because T represents getting a 2. So probability of getting a T and a T is 1 over 9. I'm just reading off the table, so that's 1 over 9. The probability of spinning 2 once only. Okay, in the sample space, where have we spun 2 once only? Okay, so 1 T only. 1 T only here, 1 T only there. Okay, so it's the probability of Tn plus the probability of Nt. So we're adding 2 branch lines together because it satisfies that condition. So that equals 2/9 plus 2/9, which equals 4 over 9. The probability of not spinning a 2. Okay, not a 2 means having no T's. So we want that one, and that one. Actually, no, we want no T's at all. We want no T's at all. Not spinning a 2. So we don't want anything to do with a T. So the only option would be an NN. Probability of NN. Reading off our probabilities, it's 4 over 9. And for part 4, spinning 2 once at least once. At least once means you can spin 2 2s, but I want 1 2 at least. So it's what I was doing before. We want this one, and this one, because this contains 2 T's, this contains 1 T, this contains 1 T. Great. Okay, so I can do this question both ways. Okay, I can add all these 3 together, or I can subtract 1 from the one that's the complement. It's up to you. So you can go probability of TT plus the probability of Tn plus the probability of Nt, which equals a 9th plus 2/9 plus 2/9 which equals 5/9, or you can go 1 minus the probability of NN, okay, something that's not T at all, which gives me everything that is T. So 1 minus 4/9 equals 5/9. So you get the same results, but the second way is a bit shorter. But you need to understand that that totals to 1, so I can use that. Okay, hopefully this helps.